So to summarize the three equations we got, dp dx equals 0, dp dy equals 0, and dp dz equals minus gamma. We can combine the three equations into a vector form. We know that there is a vector form, and this equation depicts the vector form in the x direction, right? And this on the y direction, this in the z direction. So if we write it out as a vector form, what will be the left-hand side? It will be a vector called dp dx, dp dy, dp dz, right? dp dx, dp dy, dp dz. This is written in a coordinate form, or you can obviously write it as a vector form. Say it is dp dx times the x component, the x direction, unit vector, right? dp dy times the y direction, dp dz times the unit vector in the z direction. Well, the bottom line is, what is this vector? This vector has a name. It's called the gradient of P. You know, d dx, d dy, d dz, this vector is an operator, essentially. This is called the nebula or del operator, and it's written this way, right? So the left-hand side will be the pressure gradient. So what will be the right-hand side? The right-hand side will be a vector which is 0, 0, minus gamma, right? In the x direction, we do not have any contribution. In the y direction, we don't either. But in the z direction, we do have a component which is minus gamma. So we can say the right-hand side will be minus gamma times the unit vector in the z direction. But let's write it out as something we are more familiar with. Let's say, remember what is gamma? The gamma is rho g, right? The density times the gravity acceleration, and this times the z direction. But remember, the gravity acceleration, the gravity acceleration itself as a vector is what? Is its magnitude times its direction. What will be the direction of gravity acceleration? In our case, minus z direction. Remember, we defined the z direction to be vertical up, right? But the direction of g will be vertical down. So that will be minus g times the z direction. Usually we just write the magnitude of g, or the absolute value of g, just as g here. So we can say the g vector is just minus g times the z direction. Okay, so we see this is what we are going to write here, right? And this is equal to this. But here we recognize minus gz here, right? So what's this basically equal to? Rho times g vector. Rho times g vector. So this is what we call the hydrostatic law.